Hello and welcome to the video number 6 of our NVIDIA Omniverse Basic Training. And today we are going to be using the synthetic data that we generated in our previous video to fine-tune a model that then we can deploy for our application. Before that, we need to set up our system. So if you are using Windows, you will need to install WSL, which is Linux for Windows, because we need to run all these commands in Ubuntu. Then we will download the latest drivers from NVIDIA for our GPU, and then we will install Docker because we will need to use Docker container. Once we have access to Ubuntu, we will need to update all the applications that we need in Ubuntu. We will need to install Miniconda and Jupyter, and then we will create a sandbox in Miniconda where we will be running and installing all the commands. Then we will need to download and extract the TAO Getting Started Kit, which contains all the scripts and libraries that we will need to use for this exercise. To do so, you will need to create an account in NVIDIA NGC if you don't have it yet. And once we have an account, we can retrieve a key to get access to all the APIs that we will need to run these commands, to run the models in TAO Toolkit. And finally, in the repository that we downloaded and we used in our previous video, which is synthetic data generation, we have a notebook in Jupyter. So we will be running this notebook to execute all the commands that we need. First thing we will do is to convert our datasets into TF records. We will be using then these records to train our model, the TechNet V2, for detecting our class, which is pallet jack. And finally, we will evaluate how good is our model, and we will test it with real images and synthetic data images. So let's start. Okay, so we are going to be following this guide, this notebook for Jupyter. So basically we are going to be following these steps here. And to train our fine-tune our model that we're going to train, we will be using the synthetic data that we generated in our previous video. But before that, if you are using Windows, we need to prepare our Windows machine. I have created this file to make things easier for everybody to follow up. These first 3 steps are only for all of you that are using Windows, because to run all these commands, you need Ubuntu. Okay. So if you are using Ubuntu already, if you are using like an AWS workstation with Ubuntu for Omniverse, you don't need to do this. But if you are like me using Windows, so you will need to install WSL for Windows. In this file, you have the links to these pages. Then you will need to install the last drivers from NVIDIA. In my case is GeForce 3090 and I'm using Windows 11. Here you select, well, you can select all. And then we install Docker for Windows. I recommend to follow this order. So first we install the WSL. I was looking for another word, but it didn't work. And then we install Ubuntu after following these 3 steps. We install the last drivers, and at the end we install Docker. And once you have installed Docker, if you have WSL, normally Docker will be detecting automatically that you have installed WSL. You have all information that you need in the links that I shared. But then we go to resources, and once you have installed Ubuntu, you can select the distro, which is the operative system that you are working with. So for example, I didn't want to do all this with you because it's time consuming and doesn't make sense at all to uninstall everything just to show you. You just need to put the command in a PowerShell terminal. So you just select a PowerShell terminal, Windows PowerShell, and that's it. Okay, 1 second. That's because I'm already in sorry. That's because I'm already in Ubuntu. Yeah. So if I open a new terminal and then you run that, you land into Ubuntu. Okay. And this is my disk. That's okay. So you only need to, once you have landed in Ubuntu, we don't need this one, sorry, because we are not going to be opening a desktop in Ubuntu. You run this to have the, well, you don't need the password either. Yeah. So you only need this. Then we install Conda. Okay, I have already done that. So we can check the version of Conda that I have. Okay. Then we create a sandbox in Conda with Python 3.1, and then we activate that sandbox. Okay, it is activated, all good. And then we install Jupyter Lab, and then we run Jupyter. Let's go here. Okay, you have these options to open your Jupyter notebook. Let's select that one. And then, it's here, in labs, here. We open the notebook, and then we are going to be following the steps from here. You just need to click play, play, play. But first, let's go to the step 1. I like to do it like that. So the step 1 is to make sure that we have completed this step. We have Docker, that's okay. But in our Ubuntu machine, we need to install the container toolkit, and we need to log in with an API available. And don't forget, because inside this notebook we will be calling this variable, don't forget to set up this variable with the path to your repository. In my case, is this the path? So I leave it as an example. You need to put your own path. And this is only if you want to test that the path is correct. Let's test it here. Oh, well, I'm going to cancel this. I need to check if my path is correct here. Oh my gosh, no, nothing. It's the dollar missing here. Oh, okay, that's odd. I thought it's a good thing that I check it. So let's set the variable. Okay, that's odd. I was pretty sure I had set the variable before, but okay. Just to make sure. Okay, all good. So let's run again. Sorry about that. But yeah, just don't forget to set up this variable. Okay, perfect. Oh, oof. I cannot run this yet. First we need to... I don't know if to run it just in case. I would like to know if it works or not. It's okay. So I'm going to take a break of 1 minute. I will be back. Okay, so let's start with the step 1. Set up TAO via Docker container. So before we need to follow the prerequisites here, but obviously this page is wrong. So I have already set up the commands to follow in this file. So the first thing here is the prerequisites. You have here a video. You can follow this video. It's super interesting. We have Ubuntu with a higher version. We are using Python 3.1. You can have a look at this. Now here, this is the first command we have to run. So we need to download the TAO package that contains the startup scripts and all we need to run it. I have already run it here. So if I go up, so I have two terminals here. This first terminal is the one I'm using to run Jupyter. And the second one, I use it to install this prerequisites. But you can do this before and then you can run Jupyter. So if I go back to the file, we have done until here, okay? But you could install the prerequisites before running Jupyter if you want, but doesn't really matter. So I've been doing all that directly in my sandbox of Conda, GLab, directly in the root of the sandbox, but I'm not sure if it is necessary. You could do it as well in the root of your Ubuntu. The objective for this prerequisite is that our Ubuntu machine recognize the GPU. So you can see here that it is recognizing that we have a GeForce 390, the drivers version, and the CUDA version. But you only need to, here are the commands that you need to follow and the links if you are interested. Once you have unzipped and installed the scripts to getting started, we need to install the container toolkit. So if I go back to this one. So for Ubuntu, we configure the production repository with this command, and then we update the packages, and then we install the NVIDIA Container Toolkit. And if you scroll down, then here we have how to configure Docker. To be honest, I'm not 100% sure if maybe because I'm running this in my Windows machine and I have installed Docker in my Windows machine, I don't think I need to do this. But if you are running it directly in Ubuntu, yes, you have to do that. Even if you are using Windows machine and run it in your WSL terminal, you can also install it. It's not a problem. So you can still configure your Docker in your Ubuntu version. And then the most important thing, you need to create an account here if you don't have it yet in NGC. So let's go here. Okay, I already have an account, so I'm going to log in directly. I guess it's okay if you see my email because it's also available in my YouTube channel. Oh, what happened here? Okay, once you have logged, go to your name here, go to setup, generate API key. I need to remove all of this, but once you generate your personal key, you put a name, tech lover training, just for test for 24 hours, and we need the NGC catalog, but you can add all the services in one key. Once we generate this personal key, you copy it. You need to save it because once you go out, you will lost the key. So then, once you run this command in your terminal, here I have already logged. I don't know how to unlock. Let me check. So I can show you. Well, I don't need to show you. Just run the command docker login. And if you are not logged, you will see a request for the username, you put $auth token directly. So just to clarify, and here we just add our token. Well, I'm going to log out. So we will use this new token that I just generated, because I don't know if the previous one is already outdated. Probably the command is docker logout. I don't know. Okay, now if I log in again, okay. Let's see. Password. Perfect. And now we can go back to our Jupyter notebook. So we have installed Docker, we have installed the NVIDIA Container Toolkit, and we have login and retrieve the API key to get access to the container from NGC. And now, in theory, we should be able to run all this. So let's go for it. That should be fine. Now we are going to download the pre-trained model. Okay, just let me check again that we have the local variable well configured. Again, I don't know why it's losing the... sorry. $. My God. Maybe... And in theory it's a global variable, so it should be fine. Just in case. Okay, so I'm going to set this variable again, just in case. It's important to check these things, otherwise we don't know where we are going to save. Yeah, no, it's okay. So now should be everything okay. While you have a star here, it's because this part is running. So don't click play until we have finished the step. Perfect. So now we are going to convert the KITTI format dataset that we have generated in our synthetic data with this to convert these records into TIFF records. TIFF records are in binary format, so basically it allows our model to be trained faster since we are using binary uh, files, and it's great for bigger data sets. So the use case is image classification and object detection, but let's go for it. So we are converting the records. So now this is running. If I go back to our VS Code, so we have two new folders, TIFF records and pre-trained model. Okay, we downloaded this from TAO Toolkit, the pre-trained model that we are using, and this is the model that we are feeding our synthetic data to create our fine-tuned model. And these are the TIFF records that are being created now. I don't know if it's finished already. Yes. And the next step. Okay. Now we are going to convert the TIFF records for each of our folders with additional destructors for KITTI. So just keep an eye on the structure of the project that we have now. So this is with destructors warehouse. And now I click play with additional. Okay, so we are doing this. You can run this one as well. Forget it. So we are creating this one now, and also with no distractors. Okay. And we can go to the step 4. I don't know if we have finished this. Additional. I need to check this error, but but it's okay because we are generating the TIFI records in the correct place, so it should be okay. For this step number 4, we can have a look to the configuration file. Is this one. This is the TechNet V2 training specification file used with the NVIDIA TAO toolkit. So here's how you specify the parameters that you want to use during your training model. So if I go back here, ResNet 18 distractor spectrum. Yes, is there one? So if you want to understand these parameters, here you have a link that obviously is not working, but I'm sharing in this file the correct documentation. So if you are curious, you can find every configuration part of the file. So you only need to search for anything that you want to modify. Copying this. Okay, here you have examples and explanations. So let's go into keep going. Play. Okay. You can get. Okay, we'll leave it. I'm leaving the file as default. You don't need to modify anything for this test. Okay, let's check. I want to check this. No warnings. All good. So play. Hmm. I don't know how many GPUs I have. Okay, I guess one. Yeah, we have one. Play. Just let's have a look. So we have the pretrain model, the specs files, inference, TIFI record configuration. Okay, TIFI records. And now let's go and we are going to start training the model. This is going to take some time. Maybe, I don't know, 1 hour. Okay, so I'm going to skip time and I will be back once the training is finished. So that will generate our fine-tuned pre-trained model. And we will see the results. See you in a bit. Okay, so it took 1 hour and 45 minutes to train this model. Before we analyze the results, I saw this comment here about this variable, which should be like the path where we save the output of the model, but we don't have any if flag in these command lines. So I don't know why we have this comment here, but the result is fine because we are deploying here. As you can see in our repository, we have created this new folder, DetectNet v2, with this other folder. And here we are saving the events, and in the folder weights, we have the final output of our model ready to be exported and deployed in our application. So here in this log file, we have a few warnings, but nothing to worry about. Most of them from the Docker container, but at the end we pass. If you go through this log file, you will see several outputs, results, but here is a quick summary of what the key metrics tell us. First, the evaluation cost is very low, which means the model fits the data well. The mean average precision is over 81%, which is a strong indicator of good object detection performance. Since we trained on only one class, which is pallet jack, its average precision is the same as the mean average precision. Basically, if you had more classes, this will be the total average, and then we will have different averages per class. The model is also very fast, with inference times under 5 milliseconds per image. This is great for real-time deployment. And lastly, training throughput was about 18 samples per second, which is solid for this model size and GPU setup. So this is the key metrics that we got. And now, next thing we are going to do is to evaluate the train model. So let's go for it. Evaluate the train model. Again, this error, but this is directly related to the Docker container, so nothing to worry about. I can't remember how long this will take. So I will be back when it is finished. Okay, so it was just a few minutes. For the command line, just take note that here we are adding the path to our model. So in case that you want to evaluate a different model, you just need to change this path. We are adding as well the specification file, and at the end, so we pass. Okay. I created this comparison table with the output from our evaluation model. So that means that the evaluation model generates as well, so works well. There is no significant performance drop between training and evaluation. We already mentioned, well, the notebook mentioned that we have been using 14% of the samples reserved for this evaluation. Obviously, you cannot use samples from the ones that you use to train the model for evaluation. They need to be different samples. And all looks good. The mean average precision, this small difference means that there is no overfitting. And yeah, everything looks good. And now, if we are going back to the notebook, the final step is going to be visualize the model performance on real world data. So let's prepare for that. So let's go to visualize the model performance. This is the folder that will be created with the output of the data. This is to visualize. Well, this is an example that they are giving us, but we are going to do the same for this set of images. We are picking these images here, are all synthetic data. We have some more here. So I'm going to pick a few from here, copy. I'm going to add it to our sample of synthetic folder. I'm just curious. I didn't try that before. So let's see what happens. And now click play. I don't know how long it will take, so I will be back. Oh, so it was very quick. So we have saved the outputs in this folder. Let's check. Okay, I think I said that check very, very loud, sorry. And yeah, we have created this new folder. We have the images annotated. So you see the synthetic ones looks very good. And this is the real photo images. Boom. It's working. It's working, guys. We did it. We fine-tune our own model from scratch. This is annotation in KITTI format, okay? Okay, so I think that's all, right? Finish. I think this one is just to visualize what we just did. Well, it's mentioned in the images, so nothing will happen. Okay, so it's fine. As I said, I will be sharing this file from my drive, and probably I will be uploading this repo to GitHub. Once I do that, it will be available in the description of the video with the model already trained. First, I need to check if it's nothing with personal data here, because I'm not 100% sure. And well, I hope you like it. Now you know how to train your own model. Thank you for watching.